today's session, we're going to look at the basics of data analysis with pandas and numpy. Pandas and numpy are two packages, modules that are available with Python and are very useful for data analysis. So for today, we're really going to just look at the libraries, and next week we will look at more an analytical examples. So today is sort of an introduction to these two libraries. Should be fairly light. Let's see. Python has a huge number of libraries for supporting data analysis. The main ones that we look at here are the ones that we're going to look at here are the main ones, but that doesn't mean that we're restricted to that. So it's a good idea to sort of, whenever you're doing some kind of analysis, to use Google effectively to see what else is available and whether there's something that'll fit your own particular need. But the basics are that almost every library is going to use numpy as its underlying data structure, so to speak. But what numpy does is it supports numerical and array operations, and it's very fast. It's a very fast way of doing numerical and array operations. So that's really, most stuff is built on that. There's SciPy, which does some scientific applications, and we're not going to worry too much about it, but it has, it has a lot of capabilities for advanced like differential equations and things like that. There's pandas, which supports data manipulation and analysis, and pandas is going to be our basic data structure. What pandas will provide are basic data structures for most of what we will do in machine learning and analysis down the road in the rest of this class, in the rest of this course. And then there are various visualization libraries. There are many of them, and they all have their own strengths and weaknesses. So it's always a good idea to look and see what suits your particular application the best. So matplotlib is the basic library which sits inside pandas, and pandas has direct support for that. So that's something we will do anyway. There's Seaborn, there's Bokeh, and which are two third-party libraries that are pretty good. They have their own strengths and weaknesses, but we'll take a look at some of them along the way. There's Plotly, which is a really nice library for drawing graphs and those kind of things. There's gmplot, which is a great library for putting maps very quickly, integrating your data with the Google map. So that's Google Maps everyone understands those. So it's always a good idea to think, if you have a mapping kind of application, to see how you can put it up in a map. So the key here is that when we are talking about visualizing data, we can visualize data in many different ways. You can put a graph, a bar chart, pie chart, or you can throw in a map, or you can throw in an interactive map. That way you can sort of go in and out and drill down and get more information. There are many different ways of doing stuff, and each library has approaches this process in its own way. That means that some of them, like Bokeh, is very good at interactive mapping. gmplot is good at handling Google Maps. Plotly is good for almost any kind of thing, but it also does maps like base. Like if you want to have zip code based maps, you use shape files. Plotly integrates well with that. There's another library called Basemap that does that integration too, but probably a lot slower, but very nicely as well. So it really depends on what you want to do. So we'll take a look at a few examples as the rest of this course, but keep in mind that there is no perfect library out there. It's not that you can take one library and use that for all your visualization needs. It really depends on what you want to do. So keep that in mind and be ready to Google. So that's our introduction to the libraries. Why do we want to use numpy? Numpy is a good, or numpy or numpy, people use either term interchangeably, is very useful because it's a fast mechanism for dealing with arrays and matrices and those kind of things. It's fast, and it's also more space efficient than lists. Now the key understanding here is that the key reason for this, of course, is that a list can have different objects inside it. So you can have a list that mixes integers, strings, or even your own user-defined objects inside the same list. So what that means is that if I have a list and I'm looking at this list over here, and if I have 1 and then A and then 2 and then B, and I'm looking for the B, and I know I'm looking for, let's say, x equals this, I'm looking for x3. So x3 is b, but I can't get to this directly by saying that, hey, it's the element, the fourth element in the list, because I don't know how much space these other elements, the elements before it, these ones are using, right? I don't know because they could be of any type at all. What numpy does is it says, hey, you can't mix this stuff up. So a numpy array will contain 1, 2, 3, 4. And now if I x equals this, if I do x3, I'm sorry, then it says, hey, it's an element in the fourth place. They're integers. If an integer is in, say, 32 bits of 4 bytes or whatever, then I know that it is at byte number 3 times 4, starting from there, right? So yeah, that's right, 3 times 4. 0 times 4, blah, 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 right? 3 times 4. So it knows it's there and can go directly to that and access it. So that in a very intuitive sense tells us that it's going to be much faster than using a list. The second thing that numpy does is it's also written in written in C. So C is, as we know, is a very fast language. So we don't really want to know C because it's also a very complicated language. So numpy is written in C, so it's already faster. Even its implementation is faster than what Python is. So of course, many Python interpreters will actually be using C underlying it, but that's in principle, yes. It has good support for linear algebra, Fourier transforms, random numbers, all kinds of things. So it's very useful for any mathematical or calculations that you might want to do. And with data analysis, typically you do lots of mathematical calculations. The basic structure in numpy is the idea of an array. So there's an array. We already talked about this. An array is a sequential collection, just like a list. The only difference is that it has like objects. They have to be the same data type. The same type. So this makes index access faster because you can figure out exactly where it is. And it's also more memory efficient because you don't have to worry about the overhead of keeping different objects together. So lists are designed for things like making fast insertions. And the idea in a list is that it'll change very often. So since it's going to change very often, you want to be able to do things like insert into stuff. So in a list, roughly in a list structure, you have a list contains like memory addresses of each element, something like that, right? Some such thing. So it has a big overhead in just maintaining the list itself. NumPy arrays don't have that same overhead, and so they're a little bit more space efficient. But I don't think that's the main reason. The main reason is the faster access. They're mutable, just like in the case of lists. You can change an array. They are optimized for matrix operations. So because that's all the functions are written in with this idea that you have this like matrix or list or matrix or array or whatever, and is optimized for that. And it provides random number support. So that's the reason you really want to use NumPy.